Okay, we have written another integral. This one's from MIT Integration Bee 2019, number 15. We have the integral of e to the x times cosine squared x plus sine x cos x minus sine squared x dx. Okay, to get started with it, I just want to deal with all this stuff here, and particularly sine x cos x is really close to our double angle formula for sine. So like if we had 2 sine x cosine x, this is the same thing as sine 2x. Well, we don't have the 2 in front of this here, so what I can do is if I just multiply by a half, now this is the same as this, but let's just multiply a half on this one as well. And then what's left here, we're going to have this cosine squared x minus sine squared x. But this right here, this is our double angle formula for cosine, so this is going to be cosine 2x. So now let's just take this and this, put it back in the integral and see what we have. And then from here, now that we have it rewritten, all I want to do is let's just multiply in, let's distribute in the e to the x to each of these terms. And now having it written out like this, you can kind of see it looks like the product rule because the derivative of e to the x is e to the x. So for the product rule, we're just saying it's something in this form right here. Just because the derivative of e to the x is e to the x, the derivative of sine 2x is something like cosine 2x with some constants, but we've got this 1/2. But I think for this one, I won't really look at it this way. I'm just going to do something that's basically the same thing and do integration by parts on it. So how I'm going to do this is we'll do the DI method for integration by parts. And I'm actually just going to kind of think of it as 2 separate integrals. So what I'm going to do is I'm just going to focus on this one right here. And so for integration by parts with the DI method, I'll just have 2 columns, one to differentiate, one to integrate. I don't think it really matters that much which one we choose. So let's differentiate sine 2x over 2 and integrate e to the x. And so first I'll go ahead and integrate. So that's going to be cosine 2x over 2, and then a 2 is going to pop out, but then we can cancel 2's and we're just left with cosine 2x. Integral of e to the x, that's just e to the x. So then part of the solution's on the diagonal, so let's copy that down. We're going to have e to the x sine 2x over 2. Now here, this is going to be an integral. We're going to have minus e to the x cosine, I'm just reordering it, e to the x cosine 2x. But then when we bring this down, we'll bring this down as a separate integral now. We're going to have plus e to the x cosine 2x dx. But now these 2 integrals are identical. We're just subtracting one, so those are going to cancel off, and this is going to give us a 0 over here. And so all we're left with is this piece right here. And so for my final solution of this, we just have e to the x sine 2x over 2, add a plus c, and that's it. Okay, there you go. Good one today from MIT 2019. Thanks everyone for watching. Have a good day.